Hi everyone, this is the answer key for tonight's homework. So for the first one, we have the absolute value of 7x divided by 6 is equal to 1. So we need to first isolate the absolute value expression. So I'm going to multiply both sides by 6. So now we have the absolute value of 7x is equal to 1 times 6, which is 6. So now I can see that my absolute value expression equals a positive number, so therefore I can solve this. So we're going to first by dropping the absolute bars and setting the expression 7x equal to the negative constant, which would be negative 6, or 7x equals positive, which is 6. And from here we go and work it out. So we're going to divide both sides by 7, and x equals negative 6 over 7, or divide by 7, and x is equal to 6 over 7. And you can definitely plug those back in to make sure they do work, but since it equals a constant, I know it's going to be fine. All right, for the next one. First, I noticed that it's not isolated, the absolute value expression, so I'm going to subtract 7 from both sides. So I come up with the absolute value of b minus 2 is equal to positive 2. So I can see now that it does equal a positive constant when it's isolated. So now I write the two expressions, so b minus 2 equals negative c, so negative 2, or b minus 2 equals the positive c, which is 2. So on the left side, we're going to add 2, and we come up with b is equal to 0, or add 2, b is equal to 4. And once again, you can plug these solutions in to double check they do work. All right, for the next one, before I start solving this, I do have to isolate the absolute value expression again. So I'm going to add 8 first to both sides. So 4 times the absolute value of k over 7 equals 4. Then we would divide both sides by 4, and this isolates the absolute value expression. And now we're going to write our two equations. So k over 7 equals negative c, which is negative 1. Or k over 7 equals positive c, which is 1. So to solve this, we multiply by 7 on both sides. So in this one, k is equal to negative 7. Or on the other side, we do the same process, multiply both sides by 7. K is equal to positive 7. All right, for number 4, we do notice that it is isolated already. So when I take a look at it, it is less than a negative number, which we know is not possible. There is no way this absolute value expression can ever be less than a negative number. So this answer here is automatically no solution. For the next one, isolate the absolute value expression by adding 7. So recall that it is just like PEMDAS backwards. So the absolute value of 5q minus 1 is greater than or equal to 2 plus 7, which is 9. And since this is a greater than or equal to statement, it's going to be an or statement. So we're going to do 5q minus 1 is less than or equal to negative 9, so the negative value, or 5q minus 1 is greater than or equal to positive 9. So you do have to have these two expressions and you work them out. So I'm going to add 1 to both sides. 5q is less than or equal to negative 8. Divide both sides by 5. Q is less than or equal to negative 8 over 5. Or, and on the other side, we work it out the same way. So we're going to add 1. So 5q is greater than or equal to 10. Divide both sides by 5. Q is greater than or equal to 2. All right, for number 6, same type of problem here. So first, we're going to isolate the absolute value expression. So we'll subtract 9 from both sides. So negative 2, absolute value of 1 minus 3h is less than negative 21. Now when we divide by a negative sign here, don't forget to flip the inequality. So it went from less than to greater than. Negative 20 over 2, I'm going to just change that to a decimal, which is going to be 10.5, and it's positive. And now we see we have a or statement because it is greater than. So 1 minus 3h is less than the negative, or 1 minus 3h is greater than the positive. So we go through working this out, minus 1 from both sides. So negative 3h is less than negative 11.5. Divide by negative 3. And since we divided by that negative, we're going to flip the sign around. So h is now greater than 11.5 over positive 3. Or, now the other side I'm going to work it out just the same way. Subtract 1. Negative 3h is greater than 9.5. Divide by negative 3. And when you do that, make sure to flip the sign. So h is now less than negative 9.5 over 3. And you can definitely work that out to get your answer, but I'm going to leave it as is there. Now, one thing I'm not doing is graphing it, because this does say to graph the solutions if possible. It's just that I'm running out of space. Like the no solution would just be a number line. Here, they would be splitting apart, so I can graph it for you. So it'd be a line like this. This would be a closed circle going this way at negative 8.5, or sorry, negative 8 over 5. And this would be another closed circle at 2 going this way. So they're splitting apart, they're not together. This one would be the same thing with different numbers, just splitting apart. All right, for number 7, we're going to isolate it. First, we're going to add 1. So we come up with 1/3 absolute var of 2x plus 3 is less than or equal to 9. Here, I don't divide by 1/3. I like to multiply by the reciprocal, so I'm going to multiply both sides by 3. So the absolute value of 2x plus 3 is less than or equal to 27. So now we can see it is isolated and it's a positive number, and this is a between statement. So it's an and statement. So I'm going to do 2x plus 3 is greater than or equal to the negative number, and 2x plus 3 is less than or equal to the positive number, because it's going to be facing into each other, so it's a between statement. So first I'm going to subtract 3. So 2x is greater than or equal to negative 30. Divide by 2. And x is greater than or equal to negative 15. And other side, we're going to work it out the same way. Subtract 3 from both sides. 2x is less than or equal to 24. Divide by 2. X is less than or equal to 12. So you can leave your answer like this, but I like to rewrite it correctly, so, or in another format, negative 15 is less than or equal to x, which is less than or equal to 12. All right, so you can see I'm kind of running out of room here, so let's isolate over here now. So we're going to first subtract 4 from both sides. So we have that 5, absolute value of negative p plus 2 is greater than 0. Divide by 5. The absolute value of negative p plus 2 is greater than 0. And now it is a 0, so we can work this out here. This is going to be a between statement. So negative p plus 2 is greater than 0. This is a split, actually. Less than 0. Or negative p plus 2 is greater than 0. So we're going to subtract 2 from both sides. So negative p is less than negative 2. We divide by negative 1. And now we know that p is greater than 2. Or, and we work out the other side. So I'm subtracting 2. And dividing by negative 1, which again flips the sign. So p is now less than negative 2. And so that would be splitting apart. Less than negative 2 goes this way, positive 2 greater than goes that way. So it'd be splitting apart. And last we have number 9. So for number 9, first I'm going to subtract 4 from both sides. So we have that negative 10, absolute value of 2x plus 10 is greater than negative 80. Divided by negative 10. The absolute value of 2x plus 10 is less than 8 because we've divided by negative, we flipped the sign. This is going to be a between statement. So 2x plus 10 is greater than the negative, and 2x plus 10 is less than the positive. So then we go about subtracting and solving this. So 2x, so we're going to take away 10. 2x is greater than negative 18. Divide by positive 2. X is greater than negative 9. And subtract 10 from both sides. 2x is less than negative 2. Divide by 2. X is less than negative 1. So the between statement, I could leave it like this, but I'm going to write it as negative 9 is less than x, which is less than negative 1. All right, we're down to the last several problems here. All right, so here we're going to test these points and just plug them in here. So first off, negative 4. So when I look at negative 4, it is less than or equal to 0, so that means we plug it into this function. So negative, I plug in negative 4 plus 4. So a negative is positive, 4 plus 4 is 8. 0 is equal to 0, so once again it goes into here. So negative 0 plus 4, which is 4. 4 now. 4 falls between 0 and 5, so 2 times 4 over 3 minus 1, which is 8/3 minus 1. And here you could probably just put this in a calculator. I'm just going to work it out. 8/3 minus 3 over 3, which is 5/3. And for the last one, 84, which is greater than 5. And it's just a constant too. So every number that's 6, 7, 8, 9, 10 and bigger is going to be greater than 2, which would also 84 is, and it's just going to be 2. All right, on the other side, goes to here. Even though this says F, it should have said G. Sorry about that. This should be G for here, G for here. So let me go ahead and update that. Okay, so G of negative 2. Negative 2 is less than negative 1, so we plug it in here. So 2 times negative 2 is negative 4, plus 1 is negative 3. 0 is between negative 1 and 7, so that's going to be 3 times 0, which is 0. 1.5 is still between negative 1 and 7, so 3 times 1.5 is 4.5. And 8 is greater than 7, so 8 squared minus 2. 8 squared is 64, minus 2 is 62. And last, we're on to the piecewise function. Sketch the graph of the compound function, determine if the function is continuous or discontinuous, give the domain and range. Okay, so I'm going to do this one in purple. And I like to create the charts, but this is a constant line here, so I know they're all going to be negative 3 from negative 10 to 0. Negative 10 has an equal bar, so 1, 2, 3, closed circle. And 0 has no equal bar, so that's going to be an open circle. And there is my constant graph. So this is usually the one I don't make a table on because it's just a constant, which is a horizontal line. All right, for the second one, I am going to make a table. So it's 2x minus 3. And it tells me to start at 0 and stop at 4. So 2 times 0 is 0. 0 minus 3 is negative 3. 2 times 1 is 2. Minus 3 is negative 1. 2 times 2 is 4. Minus 3 is 1. 2 times 3 is 6. 6 minus 3 is 3. 2 times 4 is 8. 8 minus 3 is 5. Now, closed circle, closed circle. So this is going to be a closed circle, as will this. So 0, negative 3 falls right here, so it's a closed circle. So then I'm going to plot the rest of these points. And this is also a closed circle. So there's my graph right there. And then for the last one, I will do this in, let's go with red. So negative x plus 9. So x and y. So this is telling me it started at 4. And x is greater than 4, so that's going to be 5, 6, 7, and so on. So this becomes negative 4 plus 9 is 5. Negative 5 plus 9 is 4. negative 6, and then negative 7 plus 9 is 2. So we start at 4, 5, and it's a open circle, but it doesn't matter because there's already a closed circle there, so it's not going to change. 5, 4, 6, 3, 7, 2, and then we're going to draw this line and go in that direction there. Now, after I graph this, I'm going to answer the questions now. So if I trace it with my finger, it's one piece, so that it means it is continuous. The domain starts at this closed circle at negative 10, so bracket negative 10, and this arrowhead heads towards positive infinity. For the range, be careful here, the range, this is not the lowest point. This arrowhead goes towards negative infinity. So be careful, this arrow may be higher, but it does go down to negative infinity. The highest point is this here, which appears to be at positive 5, which is going to be a bracket. So there you go for that one. And for the last problem, we have the absolute value. So the absolute value of x minus 3. So we start at 4. And x is less than 4, so 4, 3, 2, 1. I'll go to 0. So we plug this in here, 4 minus 3 is 1. The absolute value of 1 is 1. We plug in 3. 3 minus 3 is 0. The absolute value of 0 is 0. 2 minus 3 is negative 1, but the absolute value of negative 1 is 1. 1 minus 3 is negative 2. The absolute value of negative 2 is 2. 0 minus 3 is negative 3, but the absolute value of that is 3. So we plot these points. Now at 4, 1, there was no equal bar, so we know it's an open circle. So at 1, 2, 3, 4, 1, open circle. And I'll plot the rest of these points. So 3, 0, 2, 1, 1, 2, and 0, 3. So I can see my graph is going to look like this. And for the last piece, we'll do this negative 1/4 x plus 2, starting at 4 again, but this time it is greater than or equal to, so 5, 6, and 7. And this will be a closed circle because there's an equal bar. So we plug in the 4 here. Negative 1/4 of 4 is negative 1. Negative 1 plus 2 is 1. You can do 5. It's negative 5/4, which is negative 1.25 plus 2, which is 0.75. And you keep going. I'm going to change this down to 8 at the bottom because I know that's going to work. So if I do 8, negative 1/4 of 8 is negative 2. Negative 2 plus 2 is 0. So I knew that would work just because it's divisible by 4. So I'm going to plot 4, 1, and it's a closed circle, so it fills in this open one. 5.75 is really close there, but I can go to 8, 0, 5, 6, 7, 8, 0, and that is going on forever, so we have this graph going here. All right, so let's talk about the domain and range real quick. Oh, actually, sorry. It is continuous because if you trace it, you do not have to lift your finger to trace the graph. The domain is going to be all real numbers because this goes towards negative infinity, this goes towards positive. And the range, this goes towards negative infinity, this goes towards positive.